Hi everybody, my name is Serge, and in this short video I'll walk you through my final project where I explored um, some capabilities of diffusion models using them as zero-shot classifiers on satellite imagery. Um, you know, why I chose this topic, it was because, diffusion models are one of the most exciting areas in generative AI, and at the same time, satellite images, like those used in the military or disaster zones, are notoriously hard to label. So I wondered, could we repurpose a generative diffusion model to classify vehicles and satellite images without retraining it? Diffusion models work by reversing noise. They start with random noise and gradually remove it to generate an image. And modern ones like Stable Diffusion do this in, compressed latent space, making things much faster and more efficient. And so we see a zero-shot classification. It's essentially means predicting things we've never trained on just by using text prompts. Models like Clip do this by comparing an image to each text label. Diffusion models can do it differently by checking which labels lead to the best denoising performance. And putting it all together, the concept comes from from a paper called "Your Diffusion Model is Secretly a Zero-Shot Classifier." In there they showed that you can treat denoising error as a similarity score. If a prompt helps the model denoise more accurately, it's probably the right class. And this diagram right here shows that process visually. Excuse me. I tested this on the xView dataset, which is a large satellite dataset with over about 260,000 vehicles, but it's heavily imbalanced. We have the small cars dominate, and some classes barely appear. So I cropped the vehicles to the bounding boxes or from the bounding boxes, and I applied 40 class or created 40 class prompts and used Stable Diffusion to compare denoising errors per the prompt. And the final accuracy was not that great. It was about 1%, lower than randomly guessing. But this wasn't noise. The model often chose semantically similar classes, and surprisingly, some rare categories like crane truck had the highest recall. So it's reasoning based on learned priors, even if the match is not perfect. So what's next? The next steps, try model strain directly on satellite images, optimize the class prompts or combine diffusion priors with traditional classifiers for better results. This experiment essentially showed me it's possible. It's just not ready for deployment where I have it right now. But yeah, thank you so much for watching. If you're curious, check out my longer video or the notebook for all the details. Thank you.